So all the slides and the elaborate explanation has been prepared, will be delivered by Dr. Vinod Kumar, Associate Professor, Department of CSE, Data Science, ATM College of Engineering and Medicine. Before going with actual uh, conduction of the program, so these are the brief introduction about the course lab overview, key microvision, ARM, NXP, LPC 2148. So we'll start with the lab program now. Coming to the course overview, course objective. So the first objective will give overview about understand the fundamental concepts of ARM-based system and basic architecture of risk consists. And the second objective is getting familiarized with ARM programming module along with register, CPSR and flags, CPSR and flags. Develop arithmetic assembly level programming for various instruction, arithmetic, logical, and all using ARM controller programming instructions. And we need to understand the exception and interrupt handling mechanism in microcontroller and discuss about the ARM firmware package and cache memory policies. So these are the objectives about the course microcontroller. Moving on. So these are the experiment wherein stated by VTU from each module. Module 1 is about observing the register dump instruction, CPSR, and the simple assembly language programming. Module 2 about develop and simulate ARM, ALP, data transfer, arithmetic, and logical operations. We need to demonstrate with suitable programs and assembly level program to multiply through 16-bit memory to find the sum of 10 integers and to find the largest and smallest number in a given set of array of 32 numbers. Developed a ALP to count the number of ones and zeros and two consecutive memory locations. So from module 3, we will be going for C programming for ARM architecture controller using a key to sort the numbers in ascending and descending using a bubble sort algorithm. And to simulate a program in C for ARM microcontroller to find the factorial of a number. And to simulate a program in C for ARM microcontroller to demonstrate the case conservation of characters for upper and lower case and vice versa. Coming to the last two programs from module 4 and 5, demonstrate and enabling and disabling the interrupts in ARM controller and handling the, we need to demonstrate the handling of divide by zero, invalid operation and overflow exception in ARM. All the programs are simulation based. So moving on to the course outcome, at the end of the course, student will be able to learn the ARM architectural features and instruction sets, develop the program using ARM instruction set for the ARM microcontroller. You can able to explain in detail of the C compiler optimization and probability issues and apply the concept of exception and interrupt handling mechanism in developing applications and demonstrate the role of cache management and firmware in the microcontroller. Moving on to the field microvision. So field microvision is the idea and debugger which is a part of developed by a field development tool chain, which is having a numerous features as the program can able to develop the embedded applications quickly and successfully. And it is a window-based software development platform that combines the robust and modern editor with a project manager, and it integrates all the tools needed to develop the embedded application using a C, C++ compiler, macro assembler, linker, locator. Basically, it's a extra file generator. So it also gives the expertise in the developing process of the embedded system application in following manner. full feature source code editor, device database for configuring the development tool, project manager for creating and maintaining your projects, integrated make utility functionality for assembly, compiling, linking, and other features, and creating a dialog for all the development environment settings. It also gives emphasis about integrated source level assembly level debugger for a high-speed CPU and peripheral simulators, advanced GDI interface for software debugging, Flash programming utility for downloading the application program into Flashroom. And it also gives the standard device database user manual and everything in the Keel Microvision software. You can find it in the link which is shared here. Moving on. So in our laboratory, we use NXP LPC2148 ARM microcontroller. This is the overview about the pin details. Here you can see it is having a 9-volt input, or it can also operate by 5 volts or 3.3. It's having an onboard ISP programmer, Bluetooth module, Zigbee module, MIMS module. All these are with refills which can be added, GSP module, touch panel, and it is having a 2-number 20-pin input output connector, Ethernet pin of 10 pin, 2 UART, on-chip RTC, battery backup, onboard ADC and DAC tester, 4-number point LED, 4-number digital input, and USB 2.0. So these are the features. If I want to abbreviate, you can see here the listing about 8 inputs, point LEDs, digital inputs, 2 lines into 16 characters, matrix keypad, stepper motor interface, and 2 UART for the serial port communication, 2 serial apron, and the on-serial on-chip real-time clock with the battery backup, and one more is it is having a temperature sensor, pressure, and traffic data are optional. You can able to use. Moving on to the first experiment. So using a Keel software, we can able to observe the various register done CPSR with a simple ALP program. So here we are starting with a basic register level data transmission from immediate addressing mode hash into immediate addressing mode. So where 6 will be moved to R6. Before that, in this, we can able to see an assembly level program to store the data 6 and 7 in the register 6 and 7 respectively, and also move the data 6 to various register from R0 to R5, and data in R7 will be registered moved to R8 to R10. So here the first instruction is area program code read only. So this is a basic instruction. It needs to be included in all the programming. So area should be in the capital letter, and you can define this program. This can be a case sensitive, uppercase or lowercase, and code read only. So this is the instruction where you are defining the area, and the purpose of this program is writing a code, and it will be a read only instruction to the ARM processor. Here the first instructions you can see move R6, hash 06. So the hash indicates with an immediate addressing mode. Here 6 is the decimal number that will be moved to R6. Similarly, move R7 hash 07. So the 07 value, which is a decimal number, will be moved to R7. You can visualize these results in the output register block, which will be shown in later part after executing the code. Similarly, R6 will be moved to R0. Similarly to R1, R2, R3, R4. So here you can see all the instructions will be are used in uppercase. So you can use the same mechanism in writing the code. Similarly, the R6 is moved to R5. Then whatever the data that is stored in R7 will be moved to R8, R9, R10, R11, and R12. And we need to end the program. So before that, we are writing one more special instruction called stop B stop. Here B stands for branching. So the stop means it will be, this instruction will be continuously executing rather than going to the end. So what is the advantages of using a stop B stop is you can make sure that the output won't be abrupt after running of the above instruction. So it will be branching out in the same instruction. So there won't be any error. Output will be printed. So that is the one of the primary point, including stop be stop. So moving on, let us see the step-by-step operation of how to observe the various registers. So the first step is just double click on Kill Microvision 4. After clicking on the Microvision 4, you click on the new project, click on the project. So you will get a tab. So in this tab, what you need to do is you need to save the project with any of them by giving a file name. So here I have given experiment one and click on save button. So after saving, so it will redirect to the list of controllers available. In search command, you can just type LPC2148, click on the LPC2148 and click on OK. After clicking on OK, here it will show the copy startup to the project folder. Click on No. No will be used for assembly level applications. After clicking on OK, it will redirect to IDE environment. Here, click on File to create a new file. After creating a file, you need to save after writing the text, you have to give the file name with extension .asm. Here I have given program 23.asm. Click on save. After saving the file, so the color of the instruction will be changed. So here we need to add the file to the source code. Just right click on the source code. You will get a tab. Here click on add existing file to the group source code. You click on to that, it will redirect to the directory where you have created a project. Here you select the program 23. So this is the file name I had given for this instruction. After selecting that, click on OK. Automatically the program 23.asm will be added to source group 1. Now right click on that program 23.asm and click on build target, or you can directly press F7 function key in order to build the target. So it will show the rebuilding target. No zero error, zero warning. This indicates the above program is free from error. So now we will be running the program. Click on debug, start and stop debug session. So here it will ask the evaluation mode running with code size of 32K. So this is the file size it has taken. Click on OK. After clicking on OK, click on F11 to run step-by-step operations. Click on step-by-step operation. For that, you can select F11 in the function key, or you can click on this icon button. It will show each the operation one by one. You can observe the changes in the register values. Would increase the register value to display all the 8 characters. So here you can see after running the first instruction, so 007 0000006 has been moved to R6. So this ARM microcontroller is 32-bit. So 8 digits will be displayed. So the 8 digit into each digit will give 4 bits. So 8 into 4, 32 bits. So here you can see 0x indicates it's hexadecimal. Similarly, if you keep on pressing the F11, so the output can be observed in the each register step by step. Here you can see. So this is the final results where from R0 to R6, the 06 has been moved. From R7 to R12, 07 is been moved. So this is the simple instruction where we have used a register to get the immediate data to R6 and R7. Then we are moving to each register just to show how the overall process has been formulated in ARM microcontroller. So now we will move on to the actual running of the program in Keel Micro Vision. So this is my Keel Micro Vision tab. You can observe here. So here you can click on project to create. So the file has been already created. So in order to make you understand, just click on new project, new micro vision. So here let me create experiment 2. I'm saving the file. So here in search command, we can give LPC2148. This is the microcontroller we need to select. Click on OK. Here you have to press more. So this is the target and source group has been already found. Click on the file, new. Here you can write the code which has been already informed. So for time being, I've already created the code. I will open the project experiment 1. So let me remove the file which is already been preloaded. So this is my program. So first thing is I need to save the program. Here you can click on file, save as. So the file is already saved with project1.asm. Here you can see. So just right click on source file. Click on add existing program 1, add. So here you can see the program1.asm has been added to the source group. Now close. After adding, just click on the right click on program.asm. Go for F7 of build target. So the building target has been successful. It has been linked. So 0 errors and 0 warnings. The program which we have explained. So click on debug, start and stop session. So here you can see the evaluation mode has been activated, running with the code size limit of 32K. Click on OK. So this is my register output window. So this is my step input. So immediately it will come it will show the arrow mark where the first instruction. So just click on step in one by one. Here you can see the R6. In the R6, the value 06 has been moved. Similarly, move on to the next. The 7 has been moved to R7. I click on the step input, you can see R0. What is the value that is stored in R6 has been moved to R0. Similarly in R1. Similarly in R2, R3, R4, R5, R8. You can see the R7 value has been moved. Similarly, 7, 10, 9, 10, 11, 12. So at the last, even if I go for step input, it will stop. all the execution will be stopped. So for that is the purpose we will be writing stop the start. I hope the student has been understood this practical session of session 1. So let me stop the debugging. If you're having any doubts, you can ask. Thank you.